Hi, I'd like to tell you about one of my pet peeves today. That is when people use calculators to find values that they ought to know without asking the calculator. Sometimes it's something just like doing some arithmetic. If I ask you what's 13 plus 7 is, hope you know that it's 20 without punching 1, 3 plus 7 equals to find out what it is. In the same way, calculators are great as replacements for tables of values of trig functions where there's no way to remember all the different numbers that go with them. Who knows what the tangent of 28 degrees or the sine of 16.3 degrees is? Long time ago we had books that you could look up pre-calculated values for trig functions and find out. Now you've got the same utility in a graphing calculator or a scientific calculator. That's great for those. But there are some angles that arise over and over again. There are some triangles that you see in so many different situations, so many contexts, that if you have to ask your calculator every time what an approximation is for the value of one of the trig functions, whose value you could get exactly and immediately by just drawing a picture and applying the definition, you're doing it the wrong way if you use the calculator. So what I want to talk about in the lecture today are certain special shapes of triangles, certain triangles that show up over and over again, triangles whose trig function values you ought to know backwards and forwards. You shouldn't have to ask a calculator. At the very most, what you should do is sketch a little picture of the triangle on the side of your paper and apply the ratio definition to know what the values of the trig functions are. Try to wean yourself away from the calculator in these cases. I promise in the long run you'll be glad you did. I love a bargain. I like getting more than my money's worth when I go to the store. In mathematics, I love an idea that gives me lots more back than I give it. I think the unit circle idea that we're going to talk about in the lecture today is like that. If you understand the approach that the unit circle gives to trigonometry, it rolls into one stuff about right triangle trigonometry that we've studied so far, facts about relationships among the trig functions that might be hard to see if you interpret them geometrically with the unit circle. It is absolutely automatic what's going on and why it works, not from the algebra of it, but from the geometry of the unit circle. So it's not a different way of doing things, it's an extension of the old way from right triangle trigonometry to unit circle trigonometry. You'll find is a small step that gives you lots back as far as understanding all the identities and relations among the trig functions that we've been exploring so far.